In this chapter, we're going to go over the skin and body membranes. So far, we looked at the cellular level, how the different cells came together to form the tissues. Each of these cells could function independently, and they can come together to form sheets, form that epithelial tissue, or these cells can start secreting a surrounding matrix here called an extracellular matrix. They can come together and also form different tissues. Now we're going to look at the organ level where we combine different types of tissue types, so 2 or more tissue types, and they can give rise to our final organ. And so the very first thing we're going to look at are body membranes. And what are membranes? Membranes serve 2 purposes. They serve as a barrier or interface, and from internal and external environments, so you can create this area where everything is inside is kept inside, everything outside is kept outside. And then number 2, we can cover and protect internal organs. So 2 major functions. And we can classify membranes in 2 types. We can classify them as epithelial membranes, and so we saw already epithelial tissues being either that simple squamous, we can have stratified squamous, or we can have cuboidal. So we have simple cuboidal, or we can have stratified cuboidal. Okay, and so epithelial membranes, this is composed of epithelial tissue and a layer of connective tissue. Okay. All right. Connective tissue membranes. These are body membranes only composed of connective tissue. Okay. So we have 3 examples of epithelial membranes. The first one is cutaneous. We have mucus, and we have serous. There's only one type of connective tissue membrane that we're going to look at, and that's going to be synovial. Okay. Now let's start off by looking at this first epithelial body membrane being the cutaneous membrane. And if we look at it here, what do we know this as? Good, it's also known as skin. Where is it located? It's the most external body covering. And in comparison to the other membranes we have that we're going to go over, this is going to be the dry membrane. Okay. Now, we said that there are 2 distinguishing things about epithelial membranes is that they have an epithelial tissue and they have a connective tissue. And so in cutaneous membranes in our skin, specific type of epithelial tissue we have is stratified, squamous epithelia, and number 2, the connective tissue we have is dense, fibrous connective tissue which lies directly underneath our stratified squamous epithelium. Now, what is this function of this cutaneous membrane? So what is the function of your skin? Great, this is outermost. So function, outermost protective boundary or barrier of the body. Great. Now, what's the next thing we have? We have the mucous membrane. Mucous membrane, where do we find it? We find it lining the inner layer of the alimentary canal the respiratory system, the reproductive system, and the urinary system. Okay, and so we call it mucous membrane because these entire membranes, these are always going to be wet, moist membranes. Location, so anywhere you see wet, moist membranes. And because they're moist, this allows the passage of nutrients and things in and out of the cells and across these membranes. And because of that, they're often adapted for absorption or secretion. Okay, so let's go over these different areas. So alimentary canal. This is a canal that extends all the way from the mouth to the anus. And so this entire inner lining here in blue, so we're going to do the mouth right down here. Oops, I think I hit the nose, so I'm sorry. Here's the mouth. So this entire region over here. Here, all this that I'm now outlining, this is mucous membrane, that alimentary canal. Now, of the respiratory system, this is going to include the nose. Let's change this color. So we have red. Mucous membrane of the respiratory system. We're going to go over here, starting with this nose. So we have the nasal cavity. We have the pharynx. This is the pharynx area. We're going to go into the larynx, trachea, bronchi, and then bronchioles. And so all this that I'm outlining in red, this is part of that mucous membrane of your respiratory system. Now, anywhere where we have that direct opening to the external environment, you're going to find this mucous membrane. And this is why we also have the reproductive system as part of this, so the vagina and then also the urethra of the penis. And then urinary system, you have the urethra for that. Okay, so urinary system. Male's urethra is part of both reproductive and urinary system. Urethra is part of the urinary system only in females. Okay, so two different things there. Next epithelial body membrane we have is the serous membrane, and we find this lining body cavities that are closed to the external environment. Okay, and so here is a great example. I'm going to first look at these lungs. So we have an opening from that trachea, bronchi, bronchioles going into our lungs. That's where air can come in on the inside. However, we also have this membrane on the outside of our lungs that don't touch our air at all. And this is a double layer of membranes, and this is called the serous membrane. So serous membrane always comes in two layers. Okay, so we have this outermost layer surrounding this closed cavity, and that's going to be the parietal pleura. And this innermost layer surrounding the entire organ, that's going to be the visceral pleura. Okay, well, pleura deals with the lungs. Parietal is the layer, so outer layer. And so visceral is the innermost layer. Pleura, we give the term because it deals with the lungs. Okay, so we have two layers that comprise our serous membrane, the outer parietal and the inner visceral. Okay. And what is the function of this? So we said it aligns these cavities, but between these two membranes, so here I'm just going to draw it really quick. Here's a parietal. Now I'm drawing the visceral. Inside is V, outside is P. In between these two layers, we have this nice fluid. And this fluid is called serous fluid. And the function of this is to prevent friction when the organs, expand or contract. Okay, and so if you look here, as your lungs expand, it's going to increase its size here in our thoracic cavity. And as you exhale, these lungs are going to start reducing in size. And so the ability for the lungs to not generate any friction against the cavity, that's what the purpose of the serous fluid is. All right, so reduces all of that friction. Now, what type of epithelium do we have? Here we have simple squamous. Epithelium. Mostly because this thin layer allows for passage of nutrients, ions, gases in and out of the organs. Much easier. And the connective tissue we have is areolar connective tissue. Right, so two different things. Now let's go back really quick to this mucous membrane, because I don't think I went over the different types of epithelial tissue we have. And this epithelial tissue for the mucous membrane it's always going to differ based on the location or whatever the organ is. Okay, and then what about the connective tissue? Well, the connective tissue is going to be fairly the same. It's always going to be loose connective tissue. And we call this, especially when it comes to the mucous membrane, lamina propria. Okay. And as an example, how does this differ between different areas? In our digestive tract, okay, and so especially within our small intestines, we have simple columnar epithelium. So it's these long cells, especially it's designed for secretion. Within our oral cavity, we have stratified squamous non-keratinized, we'll see what keratin is in a little bit, epithelium. And any time, I believe I mentioned this last lecture, but this is key because you'll probably see this on an exam. Anytime you have a membrane or layer that's exposed to the external environment and has a lot of friction or a lot of contact with the external environment often, you're typically going to see stratified squamous epithelium. Okay, and so you'll see this in that oral cavity, your skin, vagina, and anus. Okay, so areas that you would probably see that. Now, looking at this serous membrane even further, to kind of give you an idea and more clarification to this, as I mentioned, you can imagine this serous membrane being composed of two layers. And so we can compare that to a balloon. Here's a nice regular balloon. And if you stick a fist into a balloon, what's going to happen is you're going to allow this one layer of that balloon to fall inwards and surround completely your hand while you still have your outer layer right over there. Okay, so here, and then here is your hand. Now this, if you imagine your hand is the organ, and so we have this innermost layer directly covering that organ. What layer is this again? Is it visceral or is it parietal? Great, this is that visceral layer. And the outermost layer, right over here, this is going to be closer to the cavity. And this is called what? The parietal. Good, so this is parietal. And this is visceral. And here we have air, but what is the air really going to be in one of these cavities? Good, it's going to be that serous fluid. Okay, and so because this deals with closed cavities, we have different terms. Let's go back over here. Anytime we deal with our lungs, it's always going to be pleura. Anytime we deal with our heart, we're going to call it pericardium, so either parietal or visceral pericardium. And anytime we're talking about organs within our abdominal cavity, we give it peritoneum. And so here, all of this is parietal peritoneum, all that layer outside closest to the organ cavity or to the abdominal cavity. And then here, all of this membrane touching directly the surface of all of those organs is going to be the visceral peritoneum. Okay, so it's really just one continuous layer of membrane, just depending on whether it's closer to the organ or closer towards the cavity wall. Now this last connective tissue membrane we're going to go over is the synovial membrane, and this one is located between articulating bones. And so articulation means where bones come together in close contact. And so this one is between articulating bones. Okay. And what does it contain? It contains synovial fluid. And so here is all that synovial fluid. Here is our synovial membrane. Okay, so synovial membrane here in that green. And what is the function of this? What do you think the function is of all this synovial fluid? Perfect. It reduces friction. Between articulating hyaline cartilage of those joints. And what are joints? Joints are where bones meet. Okay, so it could really help in reducing that friction as you move, as you bend your legs, bend your elbows, but also not only reduces friction, but also helps absorb the shock. So when you jump up and down as you run, it helps absorb a lot of that shock as well. All right, so that's it for the membrane. So be able to recognize the different types of membrane, recognize the different types of connective tissue or epithelial tissue that they have. Oh, and also, since I mentioned that, this has, what type of connective tissue does it have? It has soft areolar connective tissue. And do we have an epithelial membrane? No, remember this is the only one that does not have an epithelial membrane. So no epithelial membrane. Great. So now this next part and the remaining of the chapter, we're going to go over the integumentary system, and we consider this the skin. And so there's lots of functions for this integumentary system. The first thing we looked at is that boundary that it serves from the external and internal environment. So it serves as protection. Another thing is what happens when your body temperature increases and you work out a lot, you sweat. And so if you're cold, you shiver. And so your skin integumentary system is very crucial for temperature maintenance. Another thing is that it synthesizes and stores nutrients. One specific one that I do want you to know is vitamin D. And the precursor to the active form of vitamin D is within our skin. Once our UV hits it from the sunlight, we can bring this into our body. It's converted into its final form. And then eventually this is going to be the active form of vitamin D, can help maintain our bone growth and store calcium. Now, another function of the integumentary system is going to be for sensory reception. Oops. And then finally, we can have secretion and excretion. So you can sweat, you can secrete some oil. And then finally, another function of the integumentary system is that it's elastic. And so if we pull and tug at our skin, it can still hold its place. Now, where do we find the integumentary system? Where do we find our skin? We find it covering body surfaces. We also find it forming protective sheets. Protective sheets around organs. And if we look at this integumentary system, we'll notice that it's broken down into two major components. Here is this first component up here, and the second component is down over here. Okay, and this first area that we are going to first describe, this is called the cutaneous, and then we have the subcutaneous layer. So cutaneous layer, and then the subcutaneous layer. And so earlier we already saw this, a cutaneous membrane, right, that we give that term for the skin, and then we have the subcutaneous, that's a part of it. So we're going to start off by looking at this cutaneous membrane. It's composed of two major layers, the epidermis and the dermis, and we also have skin appendages attached to this cutaneous membrane. So some skin appendages, these are going to be our glands, both our oil and our sweat glands, our hair and our nails. And so looking at our epidermis, what type of epithelium do we have here as a review? Perfect. The one I tell you that you should know, it's one of the most important ones. Stratified, squamous epithelium. And our epidermis, even though it looks so thin, is actually composed of multiple layers. We have thin skin and we have thick skin. So thick skin, these are the palms of your hands and the soles of your feet. And then everywhere else is pretty much going to be your thin skin. A lot of times, this calluses that you develop, those are also areas where you get the thick skin. Now, depending on if it's thick skin or thin skin, it's going to have different number of layers of comprising the epidermis. Okay, so if it's thin skin, it's going to have 4 layers of different types of cells. And then in thick skin, we're going to have 5 layers of different cells. Okay, so each of these cells is going to comprise of one of these layers. Now, what's important about this epidermis is that it contains this protein called keratin. And keratin is this protein that's tough, water resistant, and it prevents all of this water loss. And so where else besides your skin do you think you're going to find keratin? Good. So other areas you're going to find this, you're going to also find it within your hair and your nails. Okay. And the specific cell that gives rise to all of this keratin are called keratinocytes. Now, finally, most cells are keratinocytes. Now, finally, one important thing about this epidermis is that it does not have a direct blood supply. And because it does not have a direct blood supply, it is considered avascular. So all the layers of that epidermis are these right over here. But to give us some orientation, here's a cross-section of skin. Below that epidermis is the dermis, and then finally here is that subcutaneous layer. And this is where a lot of students get confused about, is that whenever they see all these layers, they think that this is part of the dermis, but no, it's only part of this uppermost layer, epidermis over here. So just want to remind you that and be aware of your orientation. So stratum basal, you'll also see this in your textbook as stratum germinativum. And this is our mitotically active cell layer. Meaning that as it grows and divides, all of these cells will eventually force to become daughter cells, and all that's going to continue to eventually form the stratum spinosum, stratum granulosum, and then the stratum corneum. And that's why we also call this a layer that has the stem cells. So stem cells are cells that can differentiate and form any other type of cells. So we start off with the stratum basal, and then we can then form these other cell layers. Now, all of our blood supply, we just said that our epidermis is avascular, so we don't have any vessels or capillaries running through our entire epidermis. And how it does that is by simple diffusion. Down here, here's that basement membrane separating our epidermis from our dermis. And then here within our dermis, we'll eventually see we have capillaries that contain all our blood supply. And just by simple diffusion, we have nutrients over here. It's going to feed all these bottom layers, all these mitotically active cell layers. And as you get away from this nutrient and blood source, and you form these upper layers over here, what do you think is going to happen to the cells? Good, eventually they're going to start dying because they're away from all this nutrient blood source. And so eventually what we form is the stratum corneum, and these are going to be your dead cells. Now let's take this step by step. We start off with the stratum basal. And the next layer is going to be the stratum spinosum, and we know it also as a spiny layer. So I'm going to clear this off. Okay, so stratum spinosum, these cells contain thick bundles of intermediate filaments made of pre-keratin. Okay, so cells contain thick bundles of intermediate filaments made of pre-keratin. Okay, but you also notice why they're called spiny layer, spinosum, is because of all these little connections in between each of these cells. Now, as a review from your last chapter, chapter 3, what gives a cell a nice structural support? And we saw it by those two cells having beams next to each other, kind of like those barbed wire beams, or those metal beams. Good, these are desmosomes. And so desmosomes help mechanical strength, and which is the purpose of all this. Because this comprises majority of your cell layer, of your epidermis, we need to have a lot of that mechanical strength for this layer. As you pull on your skin, you're really trying to rip apart all the stratum spinosum, but it's very difficult because it can withstand all of that tension. Now the next layer we have is the stratum granulosum. And this is going to be cells that are flattened because a lot of these organelles inside of the cell are going to be deteriorating as they are getting pushed away from our blood nutrient source. So cells are flattened. The organelles are deteriorating. And then finally, a lot of the cytoplasm of these cells are going to be full of keratin granules. Okay. And in a microscope, or if you were to see a cross-section of this, and if I were to ask you to identify the layer, or in a multiple choice question, here are all those granules full of that keratin. Then finally, we have stratum corneum. And this layer is the most superficial layer of the cell, meaning it's the one closest to the outermost layer of the body. And what do we cell? Because it's away from our blood source, these cells are dead. And they're only represented by flat sacs filled with keratin. All right, so all of that protein that decreases that water retention. Okay, and really this layer Also, someone has high production of the stratum corneum, that gives rise to the dandruff. So if anybody has dandruff, this is because of this layer over here. Now, a couple other things that you will need to know is that in this example, we have 4 layers. So because we only have 4 layers, is this thin or thick skin? Good, this is an example of thin skin, because we have that 4 layers. Other things that we see here besides these layers, you'll see sensory nerve endings, which we call Merkel cells. And so anytime you put your finger on something, so let's say right now I want you to sweep your finger across your computer board or your keys, and you can notice the different types of pressure and temperature that you're feeling, and that's because of these Merkel cells. Now, another thing that we have here, so stratum basal is where you'll find your Merkel cells. Another thing you'll find in your stratum basal, here we see that in our stratum spinosum, but you'll typically find your dendritic cells. And these are for immune defense. And so anytime you have a cut, let's say you have a nail, somebody pierces yourself with a nail or thumbtack or something, that gets into your skin, gets into your stratum spinosum. On this nail is never always clean. You can have some bacteria, you can have some dust particles, different things on that nail itself. These dendritic cells can come and capture it and help break them down. And so typically they're found here in your lower layer, but this one could just be migrating to attack anything that's foreign. The last thing that you're going to find in your stratum basal are going to be your melanocytes. And your melanocytes produce the protein called melanin. And this is a melanin, this is for your pigmentation and your different skin color. And so these 3 cells you should know because it can come up on your exam. Okay, now what differs thin skin from thick skin? In thick skin, remember we have 5 layers. And that 5th layer is the stratum lucidum, and so only in thick skin. And what this stratum lucidum is, it's also dead cells, because they don't have any oxygen or nutrients. Okay? They're also filled with keratin and air. And lucidum, pretty much this clear like appearance that you see over here, all this in light pink. Stratum granulosum, I remember I told you can see it by the darkest, most pigmented layer right here. So it looks pigmented just because it's filled with all those granules. It's a stark layer. And then where do you find this? You only find it in hairless skin. Okay, so the soles of your feet and the palms of your hands. Now let's go over skin color a little further. And skin color, what gives rise to majority of your pigmentation is going to be your melanocytes. And they make the protein melanin. And which layer do we find this again? Good, stratum basal. And for those of you who said German not to them, good for you too. And the function of this is to not only give us rise to the pigmentation of our skin, but also to provide UV protection. And so, if for any of you who go out to the sun very often or quite often, what you'll notice is that your skin's going to get darker because these melanocytes are going to increase the secretion of pigmentation to help protect its underlying cells. But not only that, you also can develop freckles and moles. And what I have is a sunspot, right? So you want to wear that sunblock protection. And all of these are a response to decrease the amount of UV entry into your skin. Okay. Now another thing that gives rise to our skin coloration is keratin. And where do you find this? You can find this in carrots. And this gives rise to your yellow-orange pigmentation versus melanocytes being your yellows to your brown coloring. The last thing giving rise to your pigmentation is hemoglobin, and this gives rise to that red coloring that you can see. So it all depends on how much oxygen you have within your body. so oxygen. And if someone is choking, what color do they turn? They turn blue. So no oxygen, they turn blue. But in actuality, your blood isn't turned purple, or they don't turn blue. It's a deeper red. But that's why they turn different colors, okay? And so once again, is this coloration a result of your epidermis or underlying tissues? Good, it's not from your epidermis. This hemoglobin is actually a reflection through the dermis. And that's because our dermis has all of those vessels for our blood supply. Now, other things that can alter our skin color: redness, erythema. This is what happens if you're embarrassed. If there's an inflammation, so let's say you just get a cut, and the one thing you'll first notice is that you're having a red area. That's increased blood flow to the site of infiltration or infection. So you have inflammation. Oops. Hypertension, fever, or even having an allergy. All due to increased blood flow. Now, pallor or blanching, when it happens, this is when your skin or your face can appear pale. And what can that be because? Decreased blood flow to area. And so what happens if you have anemia? So some people can appear pale. Anemia. And also there's low or impaired blood flow to an area. Now, some of you might also have seen jaundice, and this is yellowing of the skin. And so really what this is, it's a liver disorder. When the liver itself can't break down the byproducts of red blood cells. So our red blood cells continuously are being regenerated every 120 days. Bilirubin gets broken down here within our liver. And if it's not broken down, if we have some sort of liver disorder, what happens is that can start building up within our skin and then within our bloodstream. Gets sent off here. You can see your skin starts turning yellow, and also can be picked up into the eyes. Bruises, these are hematomas. And so as the skin, as that area heals, we also have that blood cells start dying, giving off that blue or black coloration of the amount of what we consider to be for these bruises. Now here you see this guy, and so I've read this article before about this guy, and he has what it's found in his family. It's all genetic, and this is called methemoglobin. So methemoglobinemia. And what this is a condition where your red blood cells don't have enough hemoglobin, or the hemoglobin itself isn't its fully active functional form. And so what they have instead is something called methemoglobin. There's a higher amount of this, which doesn't bind oxygen molecules as readily as compared to your hemoglobin. And because of that, because you don't have as much oxygen coming into your body, what happens? Well, your body is not going to be as oxygenated, and you're going to give off this darker bluish color appearance. And so this is congenital. It is found within their bloodline. I think also in the story, you can look at this link. I think it tells you more story about him and then also his family who have this genetic disorder. Kind of crazy, huh? Poor guy. Kind of looks like Papa Smurf. All right, moving on. This next layer we have is the dermis. This is right below our epidermis. And this tissue type we have comprising our dermis is a dense connective tissue. And the function of this is strength and an ability to stretch the skin, and so allowing that body to bind together. Now here, if you look at why someone who have wrinkled skin compared to smooth skin, all that has to deal with the dermis, and that's because what's found in the dermis are collagen fibers and elastic fibers. Collagen fibers specifically will give skin its toughness, while elastic fibers will give skin its elasticity. Right. Another thing we find in our dermis are blood vessels, and so these are going to regulate our blood body temperature. And now, if we see how exactly, why is it that over time we develop more wrinkles compared to someone that's younger? This actually can also deal with your exposing yourself to the sun. So there are good things and bad things about the sun, which we're gonna look at right now. And the good thing we saw already was that the sun will activate the vitamin D, so the active form of vitamin D. So plus means good things about the sun. We generate the active form of vitamin D. And then, however, the bad things about being exposed to the sun, there's also harmful things, is that it gives rise to these premature aging because of the wrinkles. So the sun, the UV, it can start damaging all these collagen fibers and elastic fibers. And so you start losing the toughness and elasticity, which gives rise to these premature wrinkles. So bad things about the sun gives rise to premature aging, loss of elasticity. And what's also bad about this is that, remember, we have these melanocytes to help protect our underlying cells. But really, they're also there to help protect our basal cell layer. Now, if this basal cell layer gets continuously damaged, we're really careful about that DNA. If that DNA gets damaged, what can that give rise to? It can give rise to skin cancer. So we can give rise to basal cell carcinomas, and malignant melanomas. So melanomas dealing with your melanocytes, carcinomas, basal cell carcinomas, cancer of those basal cells. And once again, why is that going to be bad? Well, uncontrolled cellular growth, and it can extend into your blood vessels and travel to the rest of your body, so you can have metastasis. Okay, this dermis only is composed of 2 layers. And so here is that epidermis. Now our first layer we have is our papillary layer, or our dermal papillae, and that's this layer over here, composed of all of these projections. And these projections are called dermal papillae. And what do these contain? Found within these dermal papillae, within those loops, you'll find capillary loops. And once again, these are needed for diffusion of nutrients to the epidermal layer. Other things we have pain receptors and touch receptors. And what is also unique about this dermal papillae is that this is a layer that gives rise to your unique fingerprints. And so because of that, here we have projections. Not everybody's dermal papillae is going to be the same. Some can be longer projections compared to others, but each of these patterns that they create are very unique to each individual. And so we create fingerprints. Now below this layer, much deeper to that, this bottom layer here, this is going to be our reticular layer, and this will contain our sweat and oil glands and also deep pressure receptors. Okay. Here's that epidermis. And so most of this is, what do you think this layer is mostly? Good. Most of that is going to be that stratum corneum, all this dead skin. Here we have bottommost layer, stratum basal. This dark pigmented, what do you think this is? Good. Probably the granulosum. And then here we have the spinosum. Here is this papillary layer of the dermis, giving rise to these projections. and the reticular layer is right below. Now this next part we're talking about are the skin appendages, and we have three. We have hair, hair follicles, the nails, and then finally the glands. And all of these are going to be found within our dermis. And so the very first one we're going to look at is hair, and the function of hair is to guard the head, a second function is to shield the eyes from sun. And then the third thing is to keep foreign particles out of the respiratory tract. Okay. If we look at a hair, one hair cell itself, we're going to notice we have two major regions. Everything above our skin, this is going to be the shaft. And everything below, from here and below our skin, this is going to be the root. All right. Other things we're going to notice, we have this muscle here called the arrector pili. And what function do you think this arrector pili has? Good, so it helps stand your hair up, right? And when do you notice your hand's going to stand on end? Especially when you're cold. Remember, when these muscles contract, they're going to give off heat, which is why when you're cold, your hair stands up, because this contracts to give rise to heat. So it doesn't really seem like it helps a whole lot, but this is how we can respond to raising our body temperature. So contracts to give off heat. Now looking at this hair, we produce hair by the hair bulb and the hair follicle. Okay, so here is our hair follicle. Here's our hair bulb. Oops. Right down over here. And why are they different? Well, here in our hair bulb, this is the mitotically active layer. So the innermost layer over here, this is the mitotically active layer. And so just like our skin, as these mitotically active cells grow and divide, what's going to happen? It's going to start pushing up all those cells towards the surface of our skin. And what happens? Will they still be alive or dead? They'll be dead, right? Eventually they're going to die. And so here we have all of our blood nutrient supplies and oxygen coming up. And then as these cells get further away from our hair bulb, they're eventually going to die. Alright, so produced by hair bulb and the hair follicle consists of hard, keratinized epithelial cells, okay, and all these cells in the hair bulb are mitotically active. Okay. And so, as the cells get away, grow, and get pushed further, away from the hair bulb, they eventually will die. They'll keratinize and then die. Oops, keratinize, and die. Alright, and now another thing is that we also have melanocytes. So here in in brown, you'll also notice melanocytes, and that will give rise to the different pigmentation of your hair itself. So yes, they do contain melanocytes. The next appendage we have is the nails, and these are scale-like modifications of the epidermis itself. They are heavily keratinized, and just like our hair bulb, we have all of these strata basal layers, cells. Here we also have the stratum basal layer right here within our nail matrix. So nail matrix is this region over here. This is that mitotically active layer as well. As you continue to grow and divide and grow and divide, it's eventually going to give rise to your nail cell itself. And of course, as we get farther away from our blood source, are these cells going to be living or dead? They're going to be dead. Now, nail matrix, that's how they're responsible for the growth. If you look at your fingernail right now, is there a pigment to them? No, there isn't. And so, do you think we have melanocytes? No, we don't have any melanocytes. So, no melanocytes. Because we have no pigmentation. And if you're saying to yourself, well, our fingers appear pink, that's not because of our melanocytes. What is that from? Good, that's actually from the blood vessels, those capillary beds found within our dermis that are reflecting through our nails, reflecting through our dermis and through our nails, and that's how we can see that. Okay, so true or false? If I give you this question on the exam, true or false? The reason that the nail bed appears pink is the presence of a large number of melanocytes in the underlying dermis. You would say false. That's correct. So it's pink because of our blood supply. Now, next thing we have are glands. And there's two different glands that we have in our body. These are the exocrine glands. We have sebaceous and we have sweat glands. And so we'll first start off with looking at the sebaceous glands. Sebaceous glands, they are also they function to produce sebum, which we also call oil. And the function for this are threefold. This is a lubricant for skin. It also prevents our hair from brittling. And then finally, it helps you kill bacteria. Okay, and then where do we find this? Well, we find all of these ducts emptying all this oil. So here we have that sebaceous gland. It's going to secrete its sebum here directly into the hair follicle. And eventually it's going to go up to our skin surface. And so sometimes some people might have an infection of your sebaceous gland, and so what they'll see sometimes is their hair follicle, and then also maybe some pus or some infection, and that's if bacteria have entered into this pore and have started growing and dividing within this area, and so that's an infection. Now, next gland we have is sudoriferous glands. There are two different types, eccrine and apocrine, and both of these ducts will open up to the cell surface or to the surface of the skin. Okay. And what do these produce? Well, the other one produced oil, so these ones are going to produce sweat. And this is all stimulated by temperature. So if the body temperature is too high, we're going to start sweating. And as we sweat, and as that our sweat evaporates, we can pull some of that heat along with it. Now, what's inside this sweat? Well, sweat is composed of a couple of things. It's composed mostly of water. It does have some salt and vitamin C. And it has some metabolic wastes. Okay. Other things that we can do about sweat. So sweat, in addition to stimulating body temperature, another function is that its acidic nature can help inhibit bacterial growth. Now, the second type of sweat gland that we have is an apocrine gland, and these are sweat where the duct will empty directly into hair follicles. So two areas, the armpit and the genital area. These will begin to function at puberty. They don't have a real known function to them. They do have the same composition as the sweat that we saw down here. However, there's one more thing that they also have, and that's that they have fatty acids and proteins, well, two more things. So they also have fatty acids and proteins. Okay. Now, just like your cells of your body needs fatty acids, it also needs proteins in addition to glucose. But other things that are not inherent to our body are bacteria. And bacteria also love that protein and fatty acid. Okay, and so given these areas of your armpit or genital areas that are nice and moist and warm temperature, and they've given proteins and fatty acids, do you think this is an ideal environment for bacteria to grow or to die? Good, it's an ideal area for bacteria to grow. And this is why people who have body odor, it's not because they themselves are inherently secreting certain ways, it's because these bacteria that they have within these certain regions are consuming these products of proteins and fatty acids. They're continuing to grow. And just like you and your cells giving off waste, these bacteria are also giving off waste. And so what you smell from them are all these waste products that they are giving off. Okay? So that's why you should always keep this area nice and clean. These areas specifically nice and clean. Don't keep them moist, and those will to create hotbeds for those bacteria to grow. Now, as a review, I want you to go over this question. So sebum is responsible for all the following except makes the skin oilier during adolescence, body temperature regulation, keeps the skin soft and moist, prevents hair follicles from brittleness, and kills bacteria on the skin surface. So which one is incorrect? Good. Body temperature regulation. This is that major role of those sudoriferous glands. Perfect. Now the last thing of the integumentary system we're going to look at is the subcutaneous layer, and this is deep to the dermis, meaning it's right underneath that dermis, closer towards the body. And it's actually not technically part of the skin. However, it does anchor the skin to your underlying organs, and it's mostly composed of your adipose tissue. So it's not technically part of the skin. Skin, as we know it, is really the cutaneous membrane, being the epidermis and the dermis. And then also we can give this layer two different terms: subcutaneous, sub meaning below, and then hypo meaning below as well. So subcutaneous is a layer below the cutaneous membrane. Dermis is this layer over here, so hypo also meaning below or underneath. So hypo, right below or underneath that dermal layer. So two different terms that you can use. And the function, once again, anchors the skin to underlying organs. Okay, so that's all you really need to know for this hypodermis. Not too much from that, right? Now, this integumentary system and temperature regulation. So the skin does play a huge role in controlling your body temperature. And how is that? Well, we can, as the heat is being delivered by the dermal circulation, and we can remove that heat by the evaporation of sweat or perspiration. Okay, so if we're cold, we can deliver more blood towards this area, or our tissues and our cells of our skin. We have increased blood flow to this area. Now, this next thing we're going to look at is how the integumentary system and temperature work well together. And that's because the skin plays a major role in controlling body temperature. Now, how does it do this? Well, anytime your body temperature is too high, the skin can respond in two ways. The first thing they can do is they can increase vasodilation to remove heat. Okay, so these vessels here, they're going to become more dilated and heat can escape to the exterior regions of your body. And the second thing that can happen is an increased sweat production. And as you sweat and you perspire more, what happens? As this sweat will evaporate, it'll also help bring the heat with it. Okay? So if we fill this in, it acts as a radiator with the heat being delivered by the dermal circulation. And removed primarily by evaporation of your sweat or perspiration. Now, last concept, skin injury and repair. How does the skin repair itself? And now we're going to go over two things, how that it takes place, and also looking at skin burns. Now, the very first thing that we're going to look at is inflammation. This is the very first step. And so let's say that you have a cut. Oh, here's a paper cut, one of the most bloodiest, painful things ever, right? And so one of the first things you'll notice is the area is going to become red, right? And so this is the first step. This is inflammation. And why is it red? Because, number one, your blood flow is going to increase to the site of injury. And the second thing that's going to happen is you're going to start attracting phagocytes. And phagocytes are white blood cells that are part of the immune response. Now, why do you want more blood flow? Well, we have platelets within our blood, and they can help start clotting this area. We can also have these white blood cells, which can start engulfing anything that's foreign that has entered into our skin. Now, the second thing that happens once you have a cut is what's called scab formation. And so scab formation, this is now when that stratum basal layer of cells are going to start growing and migrating around the site of injury. So they're going to start migrating around the edges of the wound. Phagocytes are going to continue to engulf anything foreign. And finally, you're going to have clotting. So you're going to have lots of clotting around the edges, so we can start preventing any further loss of blood. Okay, so scab formation, migration of stratum basal cells around site of injury. And we have clotting around infected area. To prevent further intrusion of foreign matter and blood loss. All right, so we really want to isolate that region. Now, the other thing we're going to have is cell division and migration. And with this, we're going to have continual regeneration of all those dermis. So remember those collagen and elastic fibers. We can regenerate that by the use of fibroblasts. So continual migration of stratum basal cells surrounding the clot, and we have repair of dermis. And then finally, the third thing we have is scar formation. And so by now, our scab is no longer present, so scab is gone. Our epidermis has regenerated itself, so now we have this nice clean epidermal layer. It's whole again. And then finally, 3, we have continued dermal repair. So by 1 week, you'll still notice a site of injury because we still have those fibroblasts still working to continue to close off with the collagen and all those elastic fibers. Now the next thing we are going to look at is the idea of skin burns. And why is this important? Well, it's important to know to stop burns, especially if you have a 3rd-degree burn, is because there's a couple of dangers associated with this, and that's dehydration. You have electrolyte imbalance, so if you lose too much blood and you lose too much fluid, in turn you lose lots of electrolytes. And what happens if you have too much blood loss? Then you can have circulatory shock. Now there are 3 different types of burns that we're going to look at depending on the severity. So the 1st-degree burns, this is only when that epidermis is damaged. And the skin is going to be red and swollen. So we have inflammation to this area. Second-degree burns, this is when the epidermis and upper dermis are damaged. And your skin is red with blisters. And then finally, 3rd-degree burn. This is when this entire skin layer is destroyed. And the burn is gray, white, or black. Okay. Now this is something for sure you're going to see on your exam, and that is being able to identify the 1st, 2nd, or 3rd-degree burn, as well as whether or not there's going to be pain associated with it. So let's first start here with the epidermis, and epidermis is going to affect only this uppermost layer over here. And so if you were to get a 1st-degree burn, will you feel pain? Yes. Pain is felt. And why is pain felt? Because remember, we have those Merkel cells, those nerve cells right over here that can pick up those pressure sensations. And so if you burn that, you can also feel that pain. Now, 2nd layer we have is epidermis and dermis. We start damaging these 2 layers, so 2nd degree. And a 2nd-degree burn, do you feel pain? Good, you also feel pain. Yes. Pain is felt. We have deep pressure receptors in that reticular layer. We also have other pain receptors found through our dermis. Here, 3rd-degree burn, we've burnt through our entire cutaneous layer, so all through our epidermis and our dermis, and now we can also burn part of this subcutaneous layer as well. And so do you feel pain? No, you don't feel pain. And why not? Well, because all of our pressure and pain receptors are found only here within our dermis and our epidermis. We don't have receptors, pain receptors, in our subcutaneous layer. And this is especially crucial for people who do have 3rd-degree burn to give immediate attention to this, because since they don't feel pain, these can easily get infected. And so it's very dangerous in that sense. Okay. Now, rules of 9, how to determine how critical the burn is and the volume of fluid that is lost. And so to do this, anytime in a healthcare setting, they can divide the body into 11 different areas for a quick assessment. And each of these different regions are given a percentage such as 9. And so if we add up these different percentages, if that percentages of burn is 25% has secondary burns, this is considered critical. If 10% of the body has third-degree burns, this is also considered critical. And if there are third-degree burns of the face, hands, or feet, this is also considered critical. So what do we mean by, and how do we calculate this 25%? So here each leg is considered 9%. The trunk, anterior trunk is 18. Anterior and posterior limbs is going to be 18 all in all. So 4.5 for front, 4.5 for back, 4.5 for front, 4.5 for back. All in all, that's going to be 18. Head and neck, anterior and posterior. So front, 4.5, back is 4.5. So let's say that someone got burnt trying to save someone else, and so both of their arms got completely burned, second-degree burn. So we have one arm's going to be 9, second arm's going to be 9. So it's going to be 18% secondary burn itself. Okay. So according to this is not considered critical. All right. But now let's say that in addition to saving somebody with their arms, they had to get into the fire, and so both of their legs also got burnt. They got secondary burns. So 18 plus 9 from one leg and 9 on the other. We have 36% that is burned, second-degree burn, so now it's considered critical. Okay, and so really what you need to know for this, you don't need to memorize what is considered critical. You don't need to memorize all of this right over here, nor do you need to memorize all of these values over here. All you need to know for your exam is that in order for us to determine how critical a burn is, we're going to be using the rule of 9. And why is this important to, and the importance of this as well is what you need to know. Also, you should know whether or not you feel pain, if it's a first, secondary, or third-degree burn, and also what layers extend for this burn type. Okay, so that is it for Chapter 4.